All right, so the last thing we're going to do with radicals this year is multiplying radicals. So when you're going to multiply radicals, you multiply everything together that is currently sitting under the square root. So if I throw down an example here, if I've got square root of a times square root of b, that is going to equal the square root of a times b. Okay? And then, of course, simplify if you can. In this example, I can't simplify, but we're going to do some examples. All right, in the example, square root of 3 times square root of 5, I'm going to multiply them together. So I would have 3 times 5, which is 15. And then if I could simplify, I would simplify. But on here, I can't, so I'm done. All right, so this one says 2 square root of 6 times 3 square root of 7. So as I've written down here, we're going to multiply the outside terms like you normally would, then multiply the terms under the square root. So this, we're going to take what is 2 times 3, and under the square root, we're going to have 6 times 7. So on the outside here, we have a 6. And then underneath here, we have a 42. Now, we do want to ask ourselves, can 42 be broken down to any perfect squares? And as I think of those, I have 42, I have 142, 2 and 21. I think 3 goes into it. 3 and 14. 4 does not go into it. 5 does not go into it. And then you have 6 and 7. So because there is no perfect squares on this list over here, we have no factors that are perfect squares, this is simplified. This is reduced. All right, so here we've got square root of 18 times square root of 2. I could simplify this square root of 18 as my first step, or I can go immediately into multiplying. When I multiply them, I get the square root of 36. And as I put down here, make sure you simplify when you can. Well, the square root of 36 is simply 6. So my final answer for this one would be a 6. All right, so this problem says parentheses 2 square root 5 quantity squared. So anytime you square a square root, the end result is simply the value that was sitting under the square root. So for this problem, you're going to square the 2, and then you would square the square root of 5. Okay, so 2 squared equals 4. Square root of 5 squared would equal just 5. So your final answer for this problem would be a 20. All right, now the hint on this one is you still have to remember how to multiply polynomials. So here you've got the square root times the square root, which means you have, well, really, you've got this. So under the square root, you would have a plus b times a minus b. So I'm going to go ahead and simplify that. You could do a quick box method of the a plus b and a minus b. However you decide to do that, that is up to you. And then minus b squared. But under the square root then still would be just a squared minus b squared. Can't go anywhere with it. You have simplified it. All right, so now we got a lot of things going on. I'm going to make this a big box method just so you can see what this looks like. So we've got square root of 6, square root of 2. We have square root of 6 and a minus square root of 2. Well, square root of 6 times square root of 6 is a square root of 36, or 6. Square root of 6 times square root of 2 is the square root of 6 times 2, which is the square root of 12. Okay, over here I've got the same thing, square root of 6 times 2 with a minus, which is a minus square root of 12. You'll notice those are going to cancel. And then down here I've got square root of 2 times a minus square root of 2, so it's minus a square root of 4, or a minus 2. So my problem really is 6 minus 2, or my final answer is a 4. All right, so again, I'm going to show you this in a nice, big, easy to read box. So you have square root of 5, square root of 3, square root of 5, minus square root of 3. So again, here you've got square root of 5 times 5, which is square root of 25, or a 5. Here you have square root of 5 times 3, which is square root of 15. Here you have a minus square root of 5 times 3, so minus square root of 15. And then here you have square root of 3 times square root of 3 with a minus sign out there, so it's minus 3. you end up having 5 minus 3, or your answer is 2. All right, a little bit trickier here, just because we have variables, and I haven't been throwing a lot with variables your way. So sometimes factoring, meaning a factoring tree, can help reduce work later, but you can also just multiply it out. Properties of exponents still is a thing. And variables are a little different. To move them out of a square root, you need to divide the exponent by 2 and leave the odd amounts under the square root. So for this problem, I'm going to write it this way. So 14 I know is 2 times 7. And I'll leave my x to the 5th. And then I'm going to be multiplying another times 7 and my x to the 9th. So before I do anything, I'm going to look at this. Well, I see right away that I have 2 7s. So I can rewrite it if I want and say, okay, this is the square root of 2 times the square root of 49 times the square root of x to the 14th, because 9 plus 5 is 14. That's how I do that properties of exponents when I have the base there more than once. Square root of 2 is not going anywhere, so square root of 2 is going to stay. Square root of 49 becomes a 7, and the square root of x to the 14th is the same thing as x to the 14 over 2. So this final answer would be 7x to the 7th square root of 2 would be your final answer. So that one's a little bit trickier because that variable in there, but that's the only difference in this. And again, if you're taking the square root of a variable, you're going to take what that exponent is and divide it by 2.